Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arifbut.me. You can click the appropriate link under the lecture resource column to view the notebook in NB viewer, and you may run it online in Binder as well. The other way is to download the notebook file from the course GitHub account Arif, and all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 3.4 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. My dear students, this is the fourth session on NumPy arrays, and in today's session, first we will understand how we can index 1D, 2D and 3D arrays with the concept of negative indexing as well. Then we will understand the concept of slicing, and we have done slicing of Python list in our previous module, module 2. The difference between list and array slicing is that we can slice NumPy arrays in more than one dimensions. And another difference is that when we slice Python list, we get a completely new list, while in case of NumPy array, we get a view of the original array. Soon we will practically understand this, don't worry. And finally, we will also understand Boolean indexing, also called fancy indexing or filtering, which is an elegant way of selecting content from a NumPy array based on the logical conditions or a Boolean mask. And once again, the beauty of all these operations is that we don't have to write a single loop to perform them. So this is the agenda for today's session, which I have already discussed. So let's start playing. So this is the version of my NumPy right now. Well, my dear students, over here I am doing indexing. This is very simple for 1D arrays at least. Let me comment these, which has raised the error. Okay, so this is a simple 1D array consisting of 7 elements. I have created it using the array constructor. The data type I have mentioned is uint8 to conserve memory, of course. And if we access the 0th index, I get 4. If I access the 6th index, I get this last element 3. And of course, indexing, positive indexing start from 0 and from the left. In case of negative indexing, it starts from the right, and the first index for the negative indexing is of course -1. So if I access this array with the index of -1, I will get the last element. Hope this makes sense. And of course, you of course cannot cross the indexing, neither from the positive side nor from the negative side. It will raise the index error. Great. Let's talk about 2D NumPy arrays. So over here I have created a 2D NumPy array. 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 rows, 4 columns. Great. And if I want to access the elements, now I'm using the subscript operator twice. And in the first part, I am mentioning the row, and in the second part, I am mentioning the column. So if I access it like this, third row, second column, start from 0, 0, 1, 2, 3, third row, and 0, 1, 2, second column. So this is 4. Let me run it. And we get 4 over here. Great. My dear students, in case of 2D NumPy array, if you just mention one subscript, you get that particular row. So in case of 3, 0, 1, 2, and this 3, I will get this entire row. I hope this makes sense. So you can access the specific element, you can access the specific row as well. So in case of negative indexing, remember this negative indexing starts from -1. So row -1 means this row, the last row. And within this row, I want to access the column that is again -2. So -1 is this and -2 is this. So I got 3. And similarly, if I mention, let's suppose -3 over here, just a single subscript. So -4 and -3. This is -3. So it starts from the other way around. So this is -5, this is -4, and this is -3. 3 to 1. So I hope this negative indexing in 2D arrays is not confusing to you. So do practice this. Let me move ahead and talk about the indexing for the 3D NumPy arrays. Okay, so this is the code snippet that I've written to make you understand this concept. So this is the 3D NumPy array I have created, and the size of this array is as shown over here, 2, 3, 3. So this is a tuple. This says that this is a 3 by 3 matrix having 2 levels. This is the first level, a 3 by 3 matrix, and this is the second level, a 3 by 3 matrix. Remember, this first digit, I'm taking it as the level. So this is level 0 and this is level 1. And within each level, we have a 3 by 3 matrix. Great. So once again, if you just mention a single subscript, that is ARR sub 0, in case of a 3D matrix, you get a 2D matrix that is there at level 0. So we got this 1, 2, 3, 5, 6, 7, and 9, 0, 5. And over here I have accessed the second matrix, the matrix at level 2. So I have mentioned this 1 over here. So I have got this matrix, 3 by 3 matrix. So I hope this is clear. So let's try this as well now. So if we provide 2 subscripts to a 3D array, what we are getting right now. Remember, once again, this is a level 0, 3 by 3 matrix of level 0, and this is a 3 by 3 matrix at level 1. So I have mentioned 0, 1. So this 0 is the level, and this 1 is within that level, this row 5, 6, 7. And if I do something like this, level 1, so level 1 means this 2 by 2 matrix, and within this 2 by 2 matrix, this is the row which I want to select, and that is 0, 1, 2, 5, 8, 2. So this is what is selected over here. So just visualize, try to visualize how things move from 1D to 2D and then to 3D. And similarly, I think I do have some examples in which I am selecting a particular element, and over here I am mentioning the 3 subscript operator with this name ARR. Remember, this 0 means the level, that is this first matrix. This 1 is the row within that matrix, that means 5, 6, 7. And this final subscript 2 means from this 0, 1, and 2. This is the element which I am interested in right now. So I think this is making sense. Please do make change to these codes and try to understand them, play with them, and let me move ahead and talk about negative indexing. So once again, this is the array. I have kept the array very simple for making you understand. So this is level 0, this is level 1, and at both levels we have a 3 by 3 matrix. Okay, so -1 means this level, and -2 means within this row, because this is -1 and this is -2. And over here, -1 means this last column. So remember, negative indexing does not start from 0, rather it starts from -1. And similarly, over here I have mentioned -2. So this is level -1, this is level -2. So this is the level that I am selecting, and from within this level I've used a positive index, and that is 2. So that is 0, 1 and this 2, 9, 0, 5, and this is what is selected over here. My dear students, please do play around and need to have a very clear understanding of how indexing work in 1D, 2D and especially in case of a 3D array. Let me move ahead. Let's talk about slicing now. My dear students, we have seen slicing before as well in case of list. Remember, these are the two differences that I talked about before as well. That in case of NumPy array, we can slice them in more than one dimensions. And the other difference is that once we slice a Python list, we get a completely new list. While in case of NumPy array, we get a view of the original array. And of course, the syntax is same. We just mentioned the slice object having 3 components: start, stop and step, and all these are optional. This is only a colon that is required. If you just mention a colon over here, the default value of start is 0, which is inclusive. The default value of stop is the length end of the array, which is by default exclusive if you mention it, and the step is by default 1. So let's practically see this, and let's see the slicing of 1D arrays. I have once again created an array and written some code to make you understand this. Okay, so let's see it over here. So this is a simple 1D array consisting of 7 elements. If I just mention this colon sign over here, that means I just want to get the entire array. So I've got the entire array. And if I mention this value, that is the start value. So it will start from 3, index 3, and will go up till the end. So 0, 1, 2, 3. So it will start from 7 and will go up to the end. So this is what it has done. In case if I omit the start but mention the end, that is 4, so it will start from 0 and will end at 3. Remember, this 4 is not inclusive. So it will start from 0, 1, 2 and 3, and it will end at this element 7. And similarly, you can mention both 2 and 5. So it will start from 2, 3 and 4. So just 0, 1, 2, 3 and 4. Remember, this 5 is not inclusive. As far as the negative indexing or negative slicing is concerned, remember I have just mentioned the stop value, and that is -2. So that means -1 and -2, and of course this is not inclusive. So we will cut from 0 to this value, index 0 to this 0. Okay, so similarly we can have -1 in the beginning. In this case, I'm saying that start from the last index, that is -1, and the stop is not given, and we know the stop is already the end of the array, so we have got just this 3. Over here I have mentioned start as -1 and end as -4. Remember, it will always give you an empty list or an empty array, because the ending index must be larger than the starting index, which is not the case over here. Fine, over here I have mentioned all the 3 values, and in this case it seems to be fine. I'm going to start from -1 and I'm going to end at -4, but this time the index is -1. So I will start from -1, then I will add this index to it, -2, then -3. So I've got 3 elements, 3 to 0, 3 to 0. Great. And after all this, you see the original array remains the same. Okay, so let's see the proof of concept that I just mentioned before, and that says slicing of a Python list return a new list. So let's see this. So this is a list having 9 elements, and I have sliced this list from element 2 to 5, 0, 1, 2, 3 and 4. So these are the three elements which I have sliced and placed them in list 2. 3, 4, 5. Great. Now inside this list 2 I have changed the 0th element, that is this 3 to 9, 9. So I've successfully done that, and let me check out now list 1. List 1 is as it is, while in case of list 2 I have 99 in place of this 3. So this proves that in case of slicing of Python list, you get a new list. Great. Let me repeat the same example for Python NumPy arrays as well. Okay, so once again we have an array this time. So having 9 elements, I have sliced this array, got another array from elements 2 to 5, index 2 to 5, 0, 1, 2, 3, 4. So 3, 4, 5, these were the 3 elements that will be there in this array too. And remember, as I've already said, that it has just returned a view of the same array. So if I make change to this ARR2 and make this value 3 to 99, it will work. And after that, once you see array 1 as well as array 2, in both of these arrays, the element 3 has been replaced by 99. Hence, it is proved that the slice of a NumPy array returns a view of the original NumPy array. I hope this concept is clear to you. Okay, let's move ahead. Let's talk about slicing of 2D arrays. Well, my dear students, slicing of a two-dimensional array is very similar to slicing of a one-dimensional array. The only difference is that over here, if you see, we have two slice objects, comma separated two slice objects. Let me run this code. Okay, so we have a 5 by 4 matrix, 5 rows, 4 columns. And over here, you can see that I have used the slice operator twice inside the straight bracket separated by comma. So if it has selected all the rows and it has selected all the columns from this array, and we have got the new array. I hope this makes sense. Let's see another example. Okay, so over here what I'm doing is, fine. What I'm saying is select the second row, the row at index 0, and all the columns from all the column values from that row. So let me show you the original array. This is the original array, and I am saying that select the row at index 2, 0, 1, 2. So this is the row which is selected, and from within this array I am saying select everything. So it has selected the entire row. So this is how the slicing in case of a 2D array works. Let me see another example. So over here again the same 5 by 4 matrix, but this time I am saying select all the rows and select only column 1. So you see that from within this 2D matrix or 2D array, this column is selected. The column having values 2, 6, 2, 3, 0, 2, 6, 2, 3, 0. Once again, remember, I am selecting all the rows, and from all the rows, I am just selecting only the column at index 1, and the column at index 1 is this one, 2, 6, 2, 3, 0. Great. Let's see this example now. Can anyone tell me what will happen once we will run this? Let me copy this from here to this place and delete this from here and show you the output. Now you tell me what will be the output array after this slicing. Stop the video, try to give this answer. and meanwhile I'm moving ahead. So what I'm saying is, get the first row, 0, 1. This is the first row. And from within this row, slice from column 1 to from column at index 1 and 2. 3 is not inclusive, of course. So 0, 1 and 2. So we will just get 6 and 7. Let me run it. Great. Well, let's see this example as well and try answering it before I run it myself. Stop the video, answer it, and see what we have done over here. What I'm saying this time is select all the rows. So it has selected all the rows. And in case of columns, I am just saying that reverse them. So I have reversed the column values. So this 1, 2, 3, 4 has been changed to 4, 3, 2, 1. This 5, 6, 7, 8 has been changed to 8, 7, 6, 5. So in simple words, what I have done is I have reversed this 2D array from this horizontal view. So every row of this array, elements of every row of this matrix are reversed. Can anybody tell me that if I want to reverse the elements of every column, what change I have to do in this? Please write that on a piece of paper if you can do that. And meanwhile, let me show you that. So this is the correct answer. I have just swapped. I've just placed this value over here. So this time this 4, 7, 3, 5, 1, this is column is reversed. Great. Great. My dear students, please do practice this to have a very clear understanding. And slicing 3D arrays, of course, that can be performed in the same fashion. The only difference is that over here we have 3 commas. Right now in case of 2D arrays, slicing of 2D arrays, we have 2 slice objects separated by a single comma. And in case of 3D arrays, we will have 3 slice objects with 2 commas in between. It's a bit tricky to visualize. I will strongly recommend that you should try that at your own. And let me move ahead and talk about Boolean or fancy indexing. So this is a very important concept that is used in data science, and you will come across this fancy indexing concept when we will be talking about the pandas library and the data frame structure of pandas. Anyway, let's understand this right now for NumPy arrays. Okay, so let's see this. My dear students, the concept is very simple. What you do is you provide a condition inside the brackets. So this condition is applied on every element of the array, and wherever it is true, that particular element is filtered out and placed in the new array. Let me run it. And now try to understand. So this is the original array, an array having 6 elements, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements between the interval 1 and 100. So let me do 10 over. Okay. Over here what I'm saying is filter out all the elements from this where the elements are even. So we have even elements over here. And over here I'm saying filter out all the elements from this original array where the elements are odd. And over here the condition says where the elements are greater than 50. And over here I have joined two conditions, and I'm saying I need only those elements from this original array which are greater than 30 and less than 60. And of course this is true in this case. Let me run it again and again and again. So you see, since the original array is created using the rand function, so we are getting different outputs each time. Please play around with this. So this is what is Boolean indexing. One more point, that we can always pass a a mask to this array object over here. If you see over here inside the straight brackets to this array, I have passed a condition, and if this condition evaluates to true, this condition is applied to every element of this array, and whenever it evaluates to true, that particular element is filtered out and placed in the new array. Over here what I have done is I have created a mask containing the same number of either true or false values as the size of the array. Size of the array is 5, so I have placed 5 values over here. The value over here and over here is true. So only those elements which resides on the same index where we have true will be filtered out. So 0, 1, 2, 3. So 1 and 3, 0, 1. This 2 will be selected, and 2 and 3. This 4 will be selected. So let me run it. Oops. So it says that ARR2 Boolean index does not match. Dimension is 10, but corresponding Boolean dimension is 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, fine. So this is ARR1, and over here I have given a typo. Sorry for that. Okay, so let me make this false as well. So now only this 4 will be selected. Great. I hope this makes sense. So as far as the Boolean indexing or fancy indexing is concerned, you can mention a specific condition inside the straight brackets, and that condition will be applied to all the elements of the array, and for whichever element it evaluates to true, that element will be placed inside the filtered array, the new array. And over here we have this mask. And one more point that I think I have skipped is this note. That is unlike normal slicing which we have done above, which creates view. Remember, this Boolean and fancy array indexing creates a copy of the NumPy array. So that means a new object is created in case of fancy indexing. And of course you can use the same piece of code that I've used above to prove this concept. To prove it so that you have confidence on this. And let me do a Boolean indexing on 2D arrays, my dear students. Okay, so we have a matrix of size 5 by 5 over here. Fine. And what I want to do is I want a new matrix from this matrix that only contains rows at index 0, 2, and 3. So what I want is I want a new matrix that should contain this row 95748 and 41972 and 16798. So these 3 rows, I just want to slice this original matrix. The new matrix should have these 3 rows and of course all the 5 columns. So let's see how we can do this. So I just create a mask. In that mask I am just mentioning the row indices which I want. I want row index 0, so I have placed a true. I want row index 2, so I have placed a true over here. And I want row index 3, so I have placed a true over here. And the remaining 2 rows, that is row number 1, row at index 1 and row at index 4 is false. I have created this mask and I have passed this mask over here. And as far as the columns are concerned, I am mentioning a column over here which says select all the columns. So let me run it and see, is this a success? Well, yes. 95748, this is the row at index 0. Then this 41972, this is the row at index 2, that has been selected. And finally this 16798, this is the third row which is selected. So the shape of the resulting matrix is 3 by 5. So this is how I have created a mask. I have placed that mask over here. The rows which I want to select, placed a comma and a colon ahead. I hope this makes sense. Can anybody tell me how using the same scheme I can select specific columns. Let me see. Yes. Okay, so once again, this is the matrix, and within this matrix I just want that only this column at index 1, this one, and 2 3, and this one. These two should be selected. Only column at index 1 and 3. So can you create a mask for this? Well, yes, it's simple. A false, a true, a false, a true, and a false. So only two places we have true, at index 1 and index 3. And the other difference is that over here now you see I have placed a simple column over here that I want to select all the row elements, but in case of columns I have mentioned this mask. So let me run it. Great. So this is the mask 59164. This is what I have selected. Oops, I think, okay, let me run it again. I think it's because of previous. Okay, now it's okay. So this is 11699, 11699, and this column is 16199, 16199. So the resulting matrix is of shape 5 by 2. Great. So the issue was that I have used the same names above as well. Okay. Fine. So this is again a short quiz for you, gentlemen. So what I want to do is, this time I have a 5 by 5 matrix, but from within this 5 by 5 matrix, I want you to select the inner 3 by 3 matrix, that is 844, 646 and 685. Can you think of a mask that can do this? Remember, over here we have used a row mask to select appropriate rows. Over here we have used a column mask over here to select appropriate columns. But now what problem I am posing you is, I want from within this 5 by 5 matrix, I just want the inner 3 by 3 matrix. Please stop the video, try to do it, and meanwhile let me tell you the solution. Okay, so this is what it is. Let me go it step by step. So first of all, what I'm doing is, I'm creating a mask in which this 0th row is not selected. We have a false over here. And this last row is not selected. We have a false over here. So I just want the middle 3 rows. So middle 3 rows. So let's see. We have got the middle 3 rows. And now we have got a matrix of 3 by 5 named matrix 2. And now from within this matrix 2, if I can select this column, and this column, that is column at index 1, 2 and 3, my objective will be achieved. So let me shrink this a bit. So I want to select this and this 3 columns. So I have placed a true at index 1, a true at index 2 and a true at index 3. So, and moreover, I have passed this mask in the second place for the columns. Great. So I've got the required matrix. My dear students, can you think of doing this in one step in a more elegant fashion? Please try that. And if anybody is successful in doing that, please share your code in the comment box below. And meanwhile, let me move up over here. Yes. Okay, my dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.